Hello friends, today in this video I am going to talk about heterocycles or heterocyclic compounds. So what is heterocycles? Heterocycles contain one or more heteroatom in a ring. You can see this is the carbocycle. Carbocycle means only carbon is there. Now this is heterocycle. Heterocycle means one place, two place or three place you have heteroatom. So this is heterocycles. X, Y, Z are usually oxygen, nitrogen or sulfur. Now I think it is clear to you the differences between carbocycle and heterocycle. Carbocycle means only carbon. Heterocycles means some heteroatom like nitrogen, oxygen or sulfur present in the cycle. So word cycle is important in heterocyclic compound. Now it may be aromatic, partially or fully saturated. Heterocycles are important and a large proportion of natural product contain heterocycle compound. Many pharmaceuticals and agrochemicals contain at least one heterocyclic unit. Heterocyclic systems are important building block for new materials, processing in testing, electronics, mechanical or biological properties. Now classification of aromatic 6-member heterocycle. So if you compare with the benzene with pyridine, this is carbocycle, this is heterocycle. Why? Nitrogen is present. Now beryllium, if you compare this with benzene, this is heterocycles and this is homocycle. Now you can see the pyridazine, pyrimidine and pyrazine. These three are isomers of each other. Molecular formula same, only the positions of heteroatom at different position. So 1,2 pyridazine, 1,3 pyrimidine and 1,4 pyrazine. Now if you compare this naphthalene with quinoline and isoquinoline. Quinoline and isoquinoline are isomers of each other. What is the difference? The positions of nitrogens. Here 1, here 2. Now friends, if you compare this 5-member ring with this, so these are heterocycles. Pyrrole, furan, thiophene, imidazoles, oxazoles, thiazoles, pyrazoles, isoxazoles and isothiazoles. Indole. Now saturated and unsaturated. 4-gamma pyron aromatic dipolar resonance form. You can see 2 pyridone in this. Now you can see the saturated ethylene oxide ring has there 1 heteroatom. THF ring is there 1 heteroatom. 1,4-dioxane ring is there 2 heteroatom. Pyrrolidine ring is there 1 NH. Dihydropyrene ring is there 1 heteroatom. Now functional group chemistry, imine formation. If you have this CO, if you treat it with this primary amine, it will give this. So further H plus, you will get this imine. And then if you remove this OH, this hydrogen, then it become like this. And this is the mechanism of imine formation. So removal of water is usually required to derive the reaction to completions. If dialkylamine is used, the minimum iminium ion that is formed can't lose a proton and enamine is formed. Now enols and enolate. This is the keto form and this is the enol form. You can see the enolate. If you remove this proton, then this is enolate. So enol form is favored by a conjugation group. Avoid confusing enols generated under neutral or acidic condition with enolates generated under basic conditions. So enolates are nucleophile through carbon or oxygen but react with carbon electrophiles through carbon. You can see this is the enol ether and then you can see the formation of acetal. Enamine, you can see the formation of iminium ship base and it is under these conditions, that is enamine. So iminium ion ship base and that is the enamine. So if you check this one, so this is the form. So analogous of enols but are more nucleophilic and can function as enolate equivalents. Removal of water by distillation or trapping drives reaction to completion. Enamines react readily with carbon nucleophiles at carbon. Reaction at nitrogen is possible but usually reverses. Now function group chemistry, which is commonly building block: carboxylic acid, amides, amidines, urea, guanidines, beta diketones, beta ketoester. So building blocks for sulfur containing heterocycles. You can see if you treat it with P2S5, it converted into thioketones, thiols and thioether. So heterocyclic synthesis require carbon oxygen, carbon nitrogen bond formation using imines, enamines, acetals, enols, ether, carbon-carbon bond formation using enols, enolates and enamine. These are very important for the heterocyclic compound. So during heterocyclic synthesis, equilibrium is driven to the product side because of removal of water, crystallization of product and product stability. In next lecture, I will talk about general strategy for heterocyclic synthesis. So before starting heterocyclic chemistry, you should know the urea, guanidine, beta diketones, enamine, enols, such type of chemistry you should keep in your mind.